Students, today we shall see the 10th standard special chapter. So that is Ordinate geometry. So students, before going to start with this coordinate geometry, so we will recall what we have studied in the 8th and 9th standard. That is in the graph. So representation of a line segment in a graph. So students, so we know that. So we have noticed it. So in the previous classes. So first one is to locate the position of a point on a plane. To locate a position of a point on a plane, so we require coordinate axis. We require a coordinate axis. So in that coordinate axis, the distance of a point from the y-axis, the distance of a point from the y-axis is called its x-coordinate. Its x-coordinate, or it is called as abscissa. Abscissa. So distance from the point and the y-axis is called as x-coordinate or abscissa. Similarly, the distance of a point from the x-axis, the distance of a point from the x-axis is called as y-coordinate, or it is called as ordinate. It is called as ordinate. So abscissa means, so it is a distance from a point to the y-axis. Distance from point to the y-axis is called as abscissa or x-coordinate, and the distance from a point and from the x-axis is called as y-coordinate, or it is called as ordinate. So the coordinates of the points, x-axis, so are x comma 0, and a point on the y-axis, are of the form 0 comma y. So because here we have only the value of x, whereas in case of the value of y is 0. So here we have the value of x is 0, as it has only the value of y. So we shall see this in a simple graph. So students, you have seen this type of representation of graph in a pair of linear equations. So all linear equations you have studied in the previous class. Observe students, so this is this x dash o x. This x dash o x is a horizontal line. So this is a horizontal line. So this horizontal line is called as x-axis. We call it. So this horizontal line is called as x-axis. Similarly, so observe this line which is perpendicular to the x-axis. So this y o y dash. So this y o y dash. So it is called as vertical line. Vertical line, so which is perpendicular to the x-axis. So this is called as y-axis. Y-axis. And so here the both x and y-axis intersect at a point O. Both the axis x and y intersect at a point. So this is called as point of intersection. So this is also called as origin or origin. It is called as origin. So at this point, the values of x and y are both are 0 and 0. So you have already seen. So if you observe this partition plane, these two lines will intersect each other by making the four equal parts. Four equal parts. So each part is called as each part, this part or this part, this part. So each part is called as quadrant. That means so it is of the quarter. So 1 by 4. So each part is called as quadrant. 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 So this is a first quadrant. Similarly, if we come to the anti-clockwise direction, so this is called as second quadrant. So this is third quadrant, and this is the fourth quadrant. So students, you are already familiar with that the numbers which are to the right side of the 0 are always positive. 1, 2, 3, 4, 5, 6, 7, etc. So to the left side, -1, -2, -3, -4, -5, -6, -7, etc. So this is named on the basis of the number line. So it is named on the basis of the number line. So you already know that. So in a number line, so the numbers after the 0 to the right side of the number line are positive integers. So to the left side of the 0, they are negative integers. Similarly, so in this part they are positive 3, 4, 5, 6, 7. Similarly below are negative integers. So now observe the first quadrant. So in the first quadrant, so the point which lies in the first quadrant, if you observe the values of x and y, so if you observe the values of x and y, both are positive. Both are positive. Therefore, the sign of a point on a first quadrant so is always positive. So the first one represents the x value, second one represents the y value. So if you come to the second part, that is second quadrant, observe the value of x, they are negative integers. So here they will be negative. Whereas in case of value of y, so they are positive. So in the second quadrant, the value of x is minus and the value of y is plus. So x, y. So similarly, if you come to the third quadrant, so there the value of x are negative integers and also the value of y are both are negative. Therefore, they have the value of x and y have negative symbol. That means they are the negative integers. So similarly, so if you come to the fourth quadrant, so fourth quadrant value of x are positive and y are negative. So therefore plus and minus. So x comma y. So this is about what you have studied in the previous classes. how to represent a point on a plane. Students, so we will represent this the straight line, that means so y equals to mx plus c. It is a linear equation. It is a linear equation, but we have represented this linear equation in the coordinate system. So that is in a, so it will be always a straight line. It will be always a straight line. So now, so in this lesson, that means coordinate geometry. So it has been developed an algebraic representation of the to study the geometrical figures. So it is an algebraic representation to study the geometrical figures. So in this chapter we will see the coordinate geometry with the combination of algebra plus geometry. Okay. Now students, we will see the definition of the coordinate geometry and uses applications where we are going to use this coordinate geometry in our content or in our daily life. Students, so this coordinate geometry has been developed as an algebraic tool to study the geometrical figures. So it has been developed to study the geometrical figures by using the algebra. Therefore, coordinate geometry has been developed as an algebraic tool for studying the geometrical figures or geometry figures. So, the coordinate geometry is the branch of mathematics. It is the branch of mathematics which deals with the position of an object. It deals with the position of an object. So lying in a plane, that means where it is placed, lying in a plane. So described with the help of two perpendicular lines. Described with the help of two perpendicular lines, that is x-axis and y-axis. So the uses of the or applications of this coordinate geometry are, they are widely used or applied in various fields such as physics, engineering, navigation, seismology and art. So this is the uses and the definition of the coordinate geometry. So in this chapter, students, you will study that if they have given a point, so we will find out the distance of the point, so distance of the distance between the 2 points. So and the area of the triangle. We will see the area of the triangle if they are given the vertices of the three vertices of a triangle. They have given the 3 vertices of a triangle. So we will find out easily. We will find out the area of the triangle. So similarly, we will find out the distance between the 2 points on a plane. So another one is we will find out the ratio in which the point divides the line segment. Ratio in which the point divides the line segment. Now students, we will see. So it is the distance formula. So how will we simplify the problems? Now students, we will see the distance formula. So I will give you the simple explanation regarding the distance formula. So you will learn it in detail in your regular classes. So to clear out the distance formula we get. So how the distance formula we get. So I will explain briefly. So but you will study or you will get that detailed information in the regular classes. Students, if you observe that there are 2 points are there in a plane, in a Cartesian plane, there are 2 points are there. So first one is P. So x coordinates are x1, y1. P of x1, y1, and another point is Q. So its coordinates are x2, y2. So we have to find out the distance between these two. We have to find out the distance between these 2 points P and Q. So for this, students, we have to draw the perpendicular lines from point P and Q to the x-axis. So now I will draw the perpendicular line from point P and also from point Q to the x-axis. All these points are R and S. R and S. Now students, if you observe, so by observing this, so we will write the points. So the length of, the length of OR, so that means the distance from O to R, OR is equal to, so it is x1. Let it be x1. Similarly, the length of OS, is x2 because these 2 points lies on the x-axis only. So OS equals x2. OS equals x2. So if you observe, we want to find out the length of this RS because so if we find out the length of RS, we will get the length of the points P and Q. So therefore, length of RS equals, we know the length of O to S and also we know the length of O to R. O to S is x2, whereas in case of O to R is x1. So if we make the difference, so if we subtract from OR from OS, if we subtract OR from OS, we will get the length of this RS. So that means it will be equal to x2 minus x1. x2 minus x1. So if you subtract, so this length from, so this length and this length, we will get the value of RS. Similarly, so if we find out the length of, so this PR, length of PR equals, so this point, so here it is, that this length will be, so from point R to P, so it is Y1. It is Y1. PR, the distance from the point P from R is Y1. So and the point length of or distance of Q from point S. So that means QS is equal to Y2. So QS is equal to Y2. Now students, so I will draw a perpendicular from P to QS. I will draw a perpendicular from P to QS. So let it meet at a point T. Since I have drawn the perpendicular here, this is a right angle. Call this as T. Now, so we want to find out the length. So length of this QT. Length of this QT. So here, length of RS will be equal to PT because so this is a PTSR is a rectangle. So the opposite sides are equal. Therefore, RS equal to x2 minus x1, which will be equal to PT. Which will be equal to PT. So now students observe here. So this length PR is equal to the length ST. These two are the opposite sides of a parallelogram. So PR equals ST equals Y1. So this length is also Y1. So now, if we want to find out the length of QT, so length of QT equals length of QT will be equal to QS minus TS or ST. So that means QS length of QS minus length of ST. What we have done in this RS case. So therefore, QS, the length of QS is Y2 minus ST, which is equal to Y1. So the length of QT is Y2 minus Y1. So length of RS, or which is equal to PT, is equal to x2 minus x1. So whereas in case of length of QT is Y2 minus Y1. So why we have find out these values? So here, if you observe this figure, PTQ is a right angle triangle. So PTQ is a right angle triangle. So by using Pythagoras theorem, so we can find out the value of PQ, the length of PQ. So now students, so in a triangle PTQ, so angle PTQ is equal to 90 degree. Is equal to 90 degree. So by Pythagoras theorem, so come on, tell me what is the statement of the Pythagoras theorem. So you have already studied that chapter triangles. Yes. So in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. So if you observe, so here which is the hypotenuse here? So PQ is the hypotenuse. So PQ square equals this PT square plus PQ or QT square. Now we will substitute the values of PT and QT. So PT and QT. So the value of PT is x2 minus x1. The value of PT is x2 minus x1 whole square. x2 minus x1. So the value of PT is x2 minus x1. So square is there, x2 minus x1 whole square plus. Write down the value of 2t. So the value of 2t is y2 minus y1. y2 minus y1 whole square. So therefore pq square equals, we got the value pq square equals x2 minus x1 whole square plus y2 minus y1 whole square. So if you remove the square, so to the left side you will get the root. So pq equals square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula what we want to calculate the distance between any two points in a plane. So when we know the values of coordinate values, when we know the coordinate values, so therefore the distance between the points P and Q is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this what we call, this formula is known as the distance formula. So this is the distance formula. Distance formula. So in the regular classes, students, you will be clear by using the examples to this formula, by taking the examples. So by taking the examples also we can derive the given formula. So, but here I have told you just how we get the formula. So now we shall see that some alternatives, so which can made by using this distance formula. So another method one is, another formula is, students, so we can write distance formula. So d equals, so in place of pq we can write as a d. So this can be also written as d equals x2 minus x1 whole square plus y2 minus y1 whole square. So in place of it is the pq means it is the distance between the 2 points P and Q. So therefore in place of pq I have taken d, which stands for the distance. So d equals root of x2 minus x1 whole square plus y2 minus y1 whole square. Sin, or we can write this, either you can write this as root of, so this can be also written as x1 minus x2 whole square, x1 minus x2 whole square plus y1 minus y2 whole square, or can be written as, so x1 minus root of x1 minus x2 whole square plus y1 minus y2 whole square. So okay students, I think you have understand the distance formula how we derive. So another case is there, students. So the distance between a point from its origin. The distance between a point from its origin. So that means if I take the distance from the origin to the point P, so you observe here origin to the point P, origin to the point P. So the values of origin are x. So x1, y1 are, so they are 0, 0, 0, 0. Since the values of coordinates of the origin are 0, 0, so the distance between the origin and a point, the origin and a point will be origin and a point, point P. So then any one of these values, either so x1 will be 0, x1 and y1 will be 0, or x2, y2 will be 0. So any one of the values of x1, y1 will get 0 because the values of origin are 0, 0. So if you substitute either if you take in this formula, if x1, y1 are 0, then it will be equal to x2 square plus y2 square. So if you take x2, y2 are 0, so it will becomes x1 square plus y1 square. So therefore simply we can write, so the formula to find out the origin and a point, so P equals, it is root of x square plus y square, x square plus y square, because so there is only one point is remaining, so that is x and y. So x and 6 points, x and y are remains. So because of the values of other x1, y1 or x2, y2 you can take, so that will be equal to 0. So then it will become either x2 square plus y2 square, or if you substitute in this formula, it will become x1 square, y1 square. Therefore, simply we write, so distance d equal to root of x square plus y square. Okay, students. So have seen the, so how the coordinate geometry is helpful in the mathematics and in our daily life, and also we have seen the we have discussed about the distance formula. In the next class we will solve the problems on by using distance formula. Okay, students.